Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.4, Problem 1. This is Section 15.4, Problem 1. We want to solve the definite integral of 6x plus 5 dx from 3 to 2. So the first step is to actually solve the integral. So the 6x will be 6 over 2x to the 2. My exponent was a 1 for the 6x to the first. The 1 wasn't written. But I have the 6 from the front, and then 1 plus 1 is the denominator. 1 plus 1 is the new exponent. And then the 5, when you do the integral, is a 5x. There really is a plus c involved, but we don't have to write it. It would cancel by the time we get to the last step. And the 6 over 2x squared, let's just simplify that to 3x squared. We'll keep the 5x. And then the notation is to draw a long straight line once you've solved the integral and put in the limits that you intend to plug in, the 3 and the 2. So that's the end of the first step, solve the integral. The second step is plug in the top limit of integration. So where I have an x, this 3x squared will become a 3 times 3 squared, and then plus 5 times x becomes plus 5 times 3. And then we'll do that work. 3 squared, 3 times 3 is 9, times the 3 in front is 27. And then 5 times 3 is 15. 27 plus 15 is 42. So step 2 of the process is to plug in the top limit of integration into the answer for the integral. And we did. We put in a 3, we got an answer of 42. The third step is to put in the bottom limit of integration into our answer for the integral. So the 3x squared will become 3 times 2 squared, plus 5 times x will become 5 times 2. So 2 squared is 4, times the 3 in front will be 12. And then plus 5 times 2, 5 times 2 is 10. 12 plus 10 is 22. So that's the end of step 3. We put in the 2 from the problem and got an answer of 22. The final step, step 4, is subtract the 42 from the top limit of integration minus the 22 from the lower limit of integration. And when I do 42 minus 22, the answer to that is 20.